Okay, so we're looking at this question. We have to derive y equals x to the power x. All right. So here, the first thing that you need to do, colleagues, is this power, this exponent here. You need to bring it down. Okay. So we're going to using logarithms. All right. This exponent is going to be brought down to this. Okay. Whenever you want to bring an exponent down, you always include logarithms. Okay. So in this case here, y, let me put it on the side here so that let's see, y equals x to the power x. So you're going to bring in the logarithms. Okay, what you do on the left hand side, you're going to have to do on the right hand side. Okay, so as you can see here, you bring the natural log here, natural log here. It's a natural log of y equals x natural log of x. Okay, now since y has got a natural log here, so we'll have to derive y and we also have to derive x. Okay, so this is where we're going to talk about implicit differentiation. Implicit differentiation just means you're deriving two variables. In our previous example, we're only deriving one variable, that was x. Now we're here with implicit differentiation, we have to also derive this y and this x and this natural log of x on the other side. Okay, so if you remember yesterday, this is how you derive logarithms. Remember the rule from yesterday, what I said? It's like this. The natural log of x, to derive it, it is x prime over x. Okay, yesterday I used the letter u. You can use whichever letter you want. Okay, any letter is okay. All right. Yes. So first we're going to derive here the natural log of y. So the derivative of the natural log of y is equal to y prime over y. Colleagues, when you see this apostrophe here, it just means you're deriving. Okay. So if we derive y to the power 1, the exponent multiply it with the coefficient, 1 times 1, that is 1. 1y. Then subtract a 1 from the exponent, 1 minus 1, that is 0. Okay, so the derivative of y is just 1. Okay, so here when we derive the natural log of y, it's going to become 1 over y. Okay, have you seen here? Y prime gives is this 1. Then this y here is this y here. Okay, colleagues? Y prime, we derived here and we got 1. This y stays as it is. So this is just the rule of thumb, colleagues. Whenever you're deriving a natural log, it's just, especially if the natural log is for a letter by itself, it's just 1 over that letter. Okay, colleagues? It is just 1 over that letter. Implicit differentiation. Okay, because here we're deriving two letters, y and x. With differentiation, you're always deriving x. So when you derive y, attach a dy dx to it. Okay, you attach a dy dx to it. Okay, if you're deriving any letter apart from x, attach a dy dx to it. Any questions before now I differentiate the right hand side? Okay, On the right hand side, have you seen we've got two different terms, x and natural log of x. So as I said, when you've got two different terms like that, that's when you bring in the product rule. Remember yesterday the product rule, colleagues? We said the product rule, all right? If we're using the letters u and v, okay, u prime v plus u v prime, okay? Or if you like the letter f, f prime g plus f g prime. So colleagues, what this is saying in basic English, because I know this is sounding like Greek, it's sounding like Greek, Chinese, or a language which you can't comprehend. What is this is saying in simple English is you're going to here this x natural log of x. Let me put it here, x natural log of x. What you're just going to do is you pick your u and you pick your v, okay, whatever letters you're comfortable with using. So in this case, we'll say, okay, x is going to be our u, and the natural log of x is going to be our v. Okay, you just pick what will be my u, what will be my v, or what will be my f, what will be my g. Okay, so once you've picked your u, you write like this: u equals x. Then you say u prime, meaning when you derive x, you get 1. Okay, so you pick your u, derive it. You pick your v, derive it. Okay, colleagues? Yes. Our v is the natural log of x. V prime, when we derive the natural log of x, remember as I said, natural log of x, x prime over x. X prime means you're just going to derive this x. When you derive this x, it becomes a 1. You just say 1 over x. Okay. Then using the same product rule, let me put it here like this. Product rule said u prime v plus u v prime. So u prime is this 1. V is natural log of x. So I say 1 natural log of x okay, plus u is x, okay, and then v prime is 1 over x here. So your expression is going to read like this: 1 natural log of x plus x times 1 over x. Okay, here, this is multiplication here. Okay, 1 natural log of x, so you put our answer here, 1 natural log of x plus x times 1 over x. Any questions? All right. We simplify. Here, x times 1 over x, you cross these out. You remain with 1 natural log of x plus 1. Then here you have 1 over y dy dx. Okay. Yes. Any questions before I move further? Okay. So now, with implicit differentiation, Okay, you want to make dy dx the subject of the formula. Okay, you want to make this dy dx the subject of the formula, meaning we have to get rid of this y this side. So how we get rid of this y this side? Multiply it by y. Okay, you multiply this expression times y. What you do on the left hand side, you do on the right hand side. Okay, y times 1 over y, they cancel each other out. So you have dy dx equals natural log of x plus 1 with y in the brackets there. And you can simplify this further. You just multiply y times natural log of x. You have natural log. We'll put the y in front so that we know that's just natural log of x. So you say y natural log of x plus y times 1, that is y. So this is the answer. Y natural log of x plus y. Okay, remember these are questions from thing, your past papers. So you might see this question. Okay. Yes, that's how you derive this. There are no questions. Excuse me. We can come to this question here. Okay. Y equals 2x cubed natural log of x plus x cubed plus 4. Okay. So here basically we have to derive each of these terms. We derive this, we derive this, we derive that. So we're going to start with this one here. We're going to use the product rule. Why? Because there are two different terms. 2x cubed and natural log of x are two different terms. So we're going to use the product rule. So remember the product rule, you pick your u, you say, okay, my u in this case is 2x cubed. Then you're going to say u prime, meaning we're going to derive this 2x cubed. Remember, 3 times 2, that is 6x. Then subtract a 1, 3 minus 1, that is 2. So we have 6x squared. Our v is the natural log of x. So v prime, remember, when deriving natural log of x, it's x prime over x. And when you derive x, you get a 1. So it's just 1 over x. Okay, colleagues? To make life easy, when you just see natural log of x like this, when it's deriving, just put 1 over x. If it's natural log of y, 1 over y. Okay? So the product rule, remember how it is placed? You say u prime v plus u v prime. So this expression here, u prime is 6x squared. So you're going to say 6x squared. V is natural log of x. So it's a 6x squared natural log of x. Plus u, which is I think 2x cubed. V prime 1 over x. Okay. this expression here. Plus x cubed, when we derive x cubed, it's 3x squared. Okay, remember deriving, multiply the exponent with the coefficient. 3 times 1, you get 3. And you put an x here, subtract a 1 from the exponent. 3 minus 1, that is 2. So you have 3x squared there. When it's a number by itself, it disappears. So this answer can be simplified further to this: 6x squared natural log of x plus this x, we cancel it out, so here we remain with 2x squared. Okay, 2x squared plus 3x squared. Okay, meaning we can still simplify this further. Okay, 2x squared plus 3x squared, that's 5x squared. So you have 6x squared natural log of x plus 5x squared. That is the answer. This one came in your test. Yeah, I hope you put this answer there. Any questions? Okay, back to the easy ones. These are the easy ones here. Okay. The next one, y equals 2x plus x cubed multiplied by the square root of x. Here we don't need to apply the product rule. Why? Because we can simplify this. Okay. Our earlier examples, we couldn't simplify this. Like 2x cubed natural log of x, you can't simplify it further. Okay, and which other one? Which other example? Even here, x natural log of x, you couldn't simplify it further. So that's why we use the product rule. But here we can simplify this. Okay, so remember the square root of x is the same as x to the power half. Okay. Now I know most of you don't like fractions. You prefer decimals. So we can use decimals for this, okay? We can use decimals for this. Okay. So we can say 2x plus x cubed multiplied by x to the power 0.5. Okay. If you don't like fractions, you can use decimals, colleagues. All right. It will make life very easy in the test. Okay. So x to the power 0.5, we're going to multiply it with all the terms in the brackets. So x to the power 0.5 multiplied by 2x. Okay, so it's 2x multiplied by x to the power 0.5. Okay, this is where indices take place. Okay, so where we apply indices. So remember, with indices, you're adding the powers. Okay, this is x to the power 1, this is x to the power 0.5. So this becomes 2x to the power 1 plus 0.5, which is 2 to the power x, 2x to the power 1.5. Okay, here we have 2x to the power 1.5 plus X cubed multiplied by x to the power 0.5. Remember, we're just adding the indices or the exponents. So 3 plus 0.5, that's x to the power 3.5. Okay, colleagues? Decimals always make life easy. Then we can solve. We just derive here. 1.5 times 2, that is 3. I'm not mistaken. Yeah, 1.5 power times 2, that is 3. X. You subtract a 1 from the 1.5. 1 minus 1.5, that is 0.5. So you have 3 to the power 3x to the power 0.5 plus, here when we derive x to the power 3.5, it's going to be 3.5 x to the power, we subtract a 1 here, to the power 2.5. Okay, colleagues, we can, that's how we can simplify our answer. Okay, and as you can see here, this square root of x here is 3x to the power half. Okay, power half, you convert it into a square root, but if it's a decimal, you can leave it as this. You see, 7 divided by 2, that is 3.5. 5 over 2, that is the same as 2.5. So our answers tally up. That's if you use decimals. I would advise you use decimals, colleagues. It will make life easier, especially in an exam setting. Just use decimals, okay? But fractions are also okay. Okay? They are also okay. Okay. Even if we wanted here, we would have converted this into a fraction. 0.5 is 3. 0.5 is what? Is half. 2.5, that is 5 over 2. Okay. Yes. All right. Here's another question. Derive 3x to the power 4 natural log of x. This cannot be simplified further, so you know you have to use the product rule. So remember product rule, you pick your u. What is my u in this case? My u will be 3x to the power 4. When I derive my u, which is u prime here, 4 times 3, that is 12. So I have 12x to the power 3. Okay. Our v is the natural log of x. Okay. So v prime, as I said, when you just see natural log of x, you just put like this, 1 over x. That's all. Okay. So the product rule, u prime v plus v prime u. Our u prime of this u prime is 12x cubed. V is natural log of x plus v prime 1 over x times u, 3x to the power 4. We can simplify this. We remove this x here, remain with 3x to the power 3. So we're going to have 12x cubed natural log of x plus 3x to the power 3. Okay. which we can also factorize. All right, we can also factorize this. We can say, okay, what is our common factor here? Our common factor is 3x cubed. 12x cubed divided by 3x cubed. 12x cubed, natural log of x divided by 3x cubed. You're going to get 4 natural log of x plus 3x cubed divided by 3x cubed, that is 1. Okay. Yeah, so here I've just factorized it. This expression, I've just factorized it here. Okay. And you can leave the answer as it is there. Okay, we've got this one here. Okay. So here in the notes, the study notes, if you want, you can write it as this and use the product rule, or you can use the quotient rule. Remember, quotient rule is where you are dividing two different terms. Okay, quotient rule, this is the way did I write it yesterday? Quotient rule, this one here. Okay, let me write it down there. Okay, so here we're going to use the quotient rule. Okay, so quotient rule says u prime v minus u v prime over v squared. So you just pick, your u is always the numerator, so you say u is going to be x plus x squared. U prime, we derive this expression. When we derive x, we get a 1 plus, when we derive x squared, we get 2x. Our v is equal to e to the power 2x. V prime, so remember, whenever you're deriving Euler's number, e to the power x equals ex times x prime. That's how you derive e. Okay. Yesterday I wrote it like this. I just want you to be comfortable with the different letters, okay? Or e to the power u multiplied by u prime. So in this case here, when we derive e to the power 2x, first you write the e to the power 2x as it is. Then we derive this 2x. When you derive 2x, you're going to get 2. So v prime is going to be 2e to the power 2x. Okay, colleagues. And then we now simplify. Okay. U prime, that is 1 plus 2x. V e to the power 2x. E to the power 2x. Let me put it like that. Minus u, which is x plus x squared. V prime 2e to the power 2x. 2e to the power 2x over v squared. So I'm going to say e to the power 2x squared. Okay. Then if you want to simplify this further, it can be simplified. Okay. It can be simplified, or you can leave the answer like this here. You just distribute this power 2. Okay. So you can just say the answer. But if you want to simplify it further, distribute this e to the power 2x across this parenthesis. Even this 2e to the power 2x, you distribute and then you see if you can factorize. But I don't want to confuse you more, so we'll just leave it the answer like this. Put this in parentheses. Minus x plus x squared 2e to the power 2x over e to the power 4x. All right, colleagues.